All right, well, thanks for taking a few moments to get ready and get into this next topic. Topic 2.2, the law of sines. Topic 2.2, the law of sines. Now, we got ourselves here a nice little triangle. Just take a look, triangle ABC, where angle B is 29, angle C is 62, and side C is 11 and a half. And just kind of have a real simple intro question. What would SOHCAHTOA say about this triangle? What would SOHCAHTOA say about this triangle? Okay, well, it's not a trick question because the answer is it would say nothing. You can't use SOHCAHTOA unless you have a right angle. You'd be surprised, though. People want to start telling me that this side right here is the hypotenuse, but it's not across from 90. Or maybe this side right here is the opposite or the adjacent. Those words don't even exist for this triangle, okay? Because, again, it's not a right triangle. So what we need is something new. And that something new is called the law of sines. The law of sines. The law of sines is a really nice, simple, easy to use formula. And all it really is just a bunch of ratios that are equal. It says that side A to the sine of A is going to equal side B over the sine of B is going to equal side C over the sine of C. And so again, these are proportions where we have the sides with the sine of the angle, the sides with the sine of the corresponding angle. And when you line them all up, you create what's called the law of sines. Now, what you guys are going to discover is that the law of sines can be used for certain scenarios. The scenario that's actually presented in this example is going to be an angle side. It's going to be an angle side. And when you have an angle side, you can use the law of sines. Okay, now to kind of get to the cut to the chase here, the main thing is to realize that you always need a match. And when you have an angle and a matching side, you got the law of sines. Okay, because when you have a match, you'll find out that you can set up your proportion pretty easily. Okay, now sometimes what kids will do here is they will start with the match. That is, they'll start in this problem with the C's. And so 11 and a half is to the sine of 62. Now, as you continue to fill things in, you realize that you have some B, but of course you don't have side B. So we could say B is to the sine of 29. And how about our lonely little A here? Well, it's not that lonely. It's part of the triangle. It just needs to be calculated that angle A is going to come out to be 89. Okay, so we would have to find angle A, but you would find that to be 89. And now we can talk about side A with the sine of 89. Now, what I did right here is I set up like the entire proportion. But the truth is that you kind of need to just do two at a time. In other words, maybe you'll cover up the A, and now you got yourself a nice little cross multiply. Okay, make sure you play along on your calculator because you should be able to solve this. A little bit of easy cross multiplying. I'm going to show it the first time. You would end up with B times the sine of 62 equaling 11 and a half times the sine of 29. And then, of course, algebra would say that all you need to do is divide. So I'll divide both sides by the sine of 62. And that will ultimately be our side B. Put in your calculator. Take 11 and a half times the sine of 29 and divide it by the sine of 62. And you can type that all in one step. Most of the calculators that you guys have can handle that. And we come up with 10. Okay, about 10.3 for side B. Something doesn't look right there. Calculator might be in radians. Yes, my calculator is in radians. So try again. This time you get 6.3. Okay, about 6.31. Okay, now if you liked how I set this up, in other words, I set it all up in one step, you now could go after A, but to go after A, you're going to have to kind of ignore and cover up the B. And so again, we have a cross multiply. You can take 11.5 times the sine of 89, and then you'll divide that by the sine of 62. Okay, it ends up kind of being a similar process, but I'll show it here one time. Again, you get A times the sine of 62 equals 11.5, this time times the sine of 89, and we'll divide by the sine of 62. Okay, you're just solving a proportion. Cross multiply, check it out. Only one thing really changes here. We're going to do the sine of 89. And you get about 13.02. And you just solved that triangle. Remember, we're trying to solve triangles, so we found all the sides and all the angles. Okay, let me give you a little bit of theory behind this, because it is interesting that these statements up here are actually saying that each of those ratios is supposed to be equal. And so in other words, I should be able to take side A, which came out to be about 1302, and divide it by the sine of A. And then I should be able to take side B, which came out to be 631, and divide it by the sine of 29. Oh, look, it's looking like it's about the same. And I should be able to have the same proportion for the C, which, by the way, the C's were kind of the original proportion, the original ratio. Oop. And that also comes out to 2 decimal places to be about 13.02. Okay, so the law of sines, it means what it says, and it says what it means, that the ratios are equal. Try one. Here's a problem to try. This is actually the way that your problems are going to start to look, where I'm just going to give you the measurements. So angle A equals 37, angle B equals 53, and side B equals 11. So I'm just giving you the measurements, and it would be up to you to put them into a sketch, and then, of course, to take that and solve for the missing dimensions. Go ahead. This will be a good time to push pause. Try the problem. We'll meet you back here in a moment with the answer. Why are you still watching the video? Push pause and go ahead and try the problem. All right, so how did you do? It's not too hard to make a sketch. Sometimes students will say, do I have to make a sketch? You're going to find out that we have other scenarios coming, so you'll be glad that you have a sketch to help you to be sure of what it is that you have. And I do like you to see that, once again, we have a match. 53, angle B matches with side B. As soon as you have a match, okay, you're going to find out that that's going to be a good time to use the law of sines. And a lot of times people start with the matching data, 11 and the sine of 53. The only thing that's really, the next thing that we have here is angle A, so we can say A is over the sine of 37. If you want, you could do the problem in 2 steps. So we have side A, in other words, kind of just one nice little proportion, if it's easier for you to see it with just one. Again, same thing, you're going to cross multiply, and you're going to be able to get your A value. It's going to come out to be 11, the sine of 37, divided by the sine of 53. Make sure you get that in your calculator. Looks like that side of A comes out to be 8.29. Okay, and then side B is, of course, the other missing side. How did you do? Kind of want you to realize that you go back to the same proportion. You go back to 11 over the sine of 53. But of course, you had to find angle B, We're actually working on C. Okay, so side C. But you have to find side C. You have to find angle C. That's 90 degrees. Oh, 90 degrees. Does the law of sines work? Does the law of sines work with the right angle? Well, indeed it does. It turns out that the sine of 90, if you did that on your calculator, is just 1, or if you do it with the unit circle. And so all we're doing here is actually finding a little bit of some SOHCAHTOA. And so that comes out to be your side C, which is about 13.77. Now be careful, because you don't want to hurt cheap SOHCAHTOA's feelings. If you say that you don't need SOHCAHTOA anymore, you'll find out in a few lessons that it's the only thing that can save the day when we have another triangle. Okay? Angle, angle, side. We could have noted that right here also. Angle, angle, side. When you guys are ready for class, the rest of this lesson in class, we're going to be taking a look at the side-side angle. We'll be taking a look at a side-side angle scenario, and you'll find out it's also the law of sines. Okay, it's just going to require a chart, and I'll show you that chart in that lesson.